Alright, we're going to start Topic 8 worksheet. We're going to go through the first page and then the first two proofs on the next page in the video, and then in class we will finish up with the packet. So Topic 8, if you check on your unit plans, it says that Topic 8 is geometric proofs involving parallel lines. So we should already be familiar with some geometric proofs. Now we're going to implement what we know about geometric proofs into Unit 3, which is involving parallel lines. So by the end of this topic, you will be able to provide a reason that justifies why a statement is valid, and then you will also be able to either complete or create a two-column proof with missing statements and reasons. So first off, what is the purpose of a proof? The purpose is to arrive at new conclusions using previously established statements, such as definitions, properties, postulates, and previously proved theorems. So this is also where your reasons for proofs sheet, the one that we filled in that first section together, this will come in handy. And again, we'll also go in and fill in what we know, those new theorems and new angle relationships. We'll fill those in together as well. Last unit, we started with the linear pair postulate, and we used that along with other known properties to prove the vertical angles theorem. So here, this again is the vertical angles theorem. We're going to go through this and prove it again, and we're going to discuss it, and then once we've proven it, we can use it as one of our reasons. So I'm given that lines M and N are straight intersecting lines, and I would like to prove that angle 1 is congruent to angle 3. I want to start at 1 and make my way over to 3. That's what I would like to prove and be able to do. So my first statement should be the statement that is given. So it is given that lines M and N are straight and intersecting. My first reason is given. I want to get from 1 to 3, and to be able to do that, I have to kind of go through 2 first, use that as a stepping stone. I know the relationship between angles 1 and 2. They are adjacent and supplementary, so my relationship for those are that they're a linear pair. Linear pair is supplementary, so angle 1, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And that is my second statement. And the reason behind this is that this is the linear pair postulate. And a quick reminder, I can use postulates without proving them. Postulates are accepted as true without proof. So now that I have gone from 1 to 2, I want to make my way from 2 to 3. The measure of angle 2 plus the measure of angle 3 is also 180 because these two also form a linear pair. So the measure of angle 2 plus the measure of angle 3 equals 180. This again is an example of the linear pair postulate. I notice that the measure of angle 1 plus the measure equals 180 degrees, and the measure of angle 2 plus the measure of angle 3 also equals 180 degrees. So I state that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. I can state this because both individual pieces are equal to the same thing. They're both equal to 180. And this is the transitive property of equality. My goal is to prove that angle 1 and angle 3 are congruent. So I've got the measure of angle 2 here, and like I said earlier, this was kind of a stepping stone for me. So I want to get rid of it now. I'm going to subtract the measure of angle 2 from both sides, and I'm just left with the measure of angle 1 equals the measure of angle 3. The reason that allows me to subtract from both sides, as we know from last unit, is the subtraction property of equality. I don't want to leave it at this. I don't want to leave it at the measures equal each other. I would like the angles to be congruent. I want to go from being equal to being congruent. We have a definition that says just this. This is the definition of congruence. So now we've gone through and again proven the vertical angles theorem. Now we can use it as a reason in other proofs. What other postulates and established theorems do we have that we can use in parallel line proofs? So what are all the postulates and the proven theorems that we're allowed to use? Well, to start out, we know the linear pair postulate. Linear pair postulate. As it is a postulate, I don't have to prove it before I'm allowed to use it. Linear pair postulate. I also have the vertical angles theorem, VAT. So this is the vertical angles theorem. That's what we just proved above. And I'll say THM for short. We have the vertical angles theorem. We have two other postulates. We learned one on the second day of the third unit, and we learned the other one on the third day. We have the new angle relationship corresponding. That was a postulate. Corresponding angles postulate. P-O-S-T, I'll say that for short, for postulate. And we have the converse of the corresponding angles postulate. It's still a postulate even though it's the converse of it. So we have the converse of the corresponding angles postulate. So these four, along with any properties and definitions on our reasons for proof sheet, are able to be used as a reason in our two-column proofs. And we're going to be using these to prove these 8 theorems down here. So these are our new angle relationships from this unit. For example, the alternate interior angle or the alternate exterior angle. We want to prove those theorems along with the converse of all of those theorems. So let's move on to the second page of the packet, and let's try and fill in one of these proofs. Let's fill in and prove the alternate exterior angles theorem. The alternate exterior angles theorem. So I'm given that line A is parallel to line B, and we can see that it follows along in our image to the right. We have these arrows, these double arrows on our parallel lines. This indicates that they're parallel. That's what's given to us. So my first statement should be A is parallel to B, or line A is parallel to line B. My first reason for that is that it is given. I would like to prove that angle 2 is congruent to angle 8. That's what I want to prove. I need to get from 2 to 8. So just like in the last example of the proof for the vertical angles theorem, we used another angle as a stepping stone. We're going to do the same thing here. So I know that angle 2 and angle 6 are congruent. So I'm going to go from 2 to 6. I know that these two are congruent by one of our postulates. So angle 2 is congruent to angle 6. Take a look at these angles. What relationship do you think that they have? And that would be my reason. These are corresponding angles. So by the corresponding angles postulate, I know that angle 2 is congruent to angle 6. Now I can go from angle 6 to angle 8. I can jump over from 6 to 8. I know that angle 6 is congruent to angle 8 by another theorem that we have proven and we are allowed to use. They're vertical angles. So this is the vertical angles theorem. Okay, so we've used 6 as our stepping stone, and my last statement should be what I would like to prove, that angle 2 is congruent to angle 8. Angle 2 and angle 8, that's what we want to prove to be congruent. But what's my last reason here? I notice that angle 2 is congruent to angle 6, and angle 8 is also congruent to angle 6. So if both of these angles are congruent to the same angle, then they must be congruent to each other. And this is the transitive property of congruence. And it's a property of congruence because we're dealing with congruence right here. These are congruent symbols. Okay, so now we've proven the alternate exterior angles theorem. And this proof is going to be a similar process for the alternate interior angles theorem. So when we get to that one, it will be a similar proof, a similar process. Okay, let's move on to number 2. Number 2 is proving the converse of the same side interior angles theorem. So I'm proving the converse of the same side interior angles theorem. And I'm giving you that angle 6, so first off, the given is the measure of angle 4 plus the measure of angle 6 equals 180. That's my given. Plus the measure of angle 6 equals 180. This is my given. And again, I didn't mention this yet, but don't be alarmed if you have some of the statements filled in already. We're just going through and explaining how we come up with our statements. We want to give a more in-depth description versus just going from the statements and then filling in the reasons. So I would like to prove that these two angles are parallel. That's my goal. That's what I want to prove. What angle relationship do you think angle 4 and angle 2 have? Because I want to get to something that I know, get to some angle congruence. That's what my goal is. So far, all I know is that if I add these two angles, angle 4 and angle 6, if I add those measures up, I get 180. Well, what's my relationship between 4 and 2? I know that those are a linear pair. So the measure of angle 4 plus the measure of angle 2 also equals 180. And these, when you add them up, because they're a linear pair, they equal 180. This is the linear pair postulate. I'll say LPP for short. And then I notice that the measure of angle 4 plus the measure of angle 6 equals 180, and the measure of angle 4 plus the measure of angle 2 equals 180. Well, if these two pieces equal the same thing, then they must also equal each other. So the measure of angle 4 plus the measure of angle 6 equals the measure of angle 4 plus the measure of angle 2. And the reason behind this is the transitive property of equality. I see here, oh, well, I've got the measure of angle 4 on both sides. I can get rid of that. I'm going to subtract that. If I subtract the measure of angle 4 from both sides, I'm just left with the measure of angle 6 equals the measure of angle 2. And the reason that let me do that, this was the subtraction property of equality. I want to get to some congruence. So if I have some congruence, then I can prove that my lines are parallel. And I'm getting to the point where I'm showing that angle 6 and angle 2 might be congruent. And I have a converse postulate that tells me that if those are congruent, then my lines are parallel. That's where I want to get. So if I go from the measure of angle 6 equals the measure of angle 2, I know that angle 6 is congruent to angle 2. And those are congruent by the definition of congruence. I know that if the measures are equal, then the angles are congruent. So this is the definition of congruence. So if we remember, with our conditional proof, lines are parallel, then my angle that I can use, whether congruent or supplementary. But when we're using a converse, I'm saying if I have that, then my lines are parallel. So I'm trying to use, well, proving I know the converse of the corresponding angles postulate. If I can use that, then I know my lines are parallel. Well, that's exactly what I have. Angle 6 and angle 2 are congruent. Therefore, line A is parallel to line B because this is the converse, CONV for converse, of the corresponding angles theorem. So we've gone through, we started with having same side interior angles adding up to 180. We wanted to prove that that meant the lines are parallel. So beginning with having that, we were able to prove using the postulate that we know. Oop, I made a mistake, that's not a theorem. converse of corresponding angles, this is a postulate, and that's super important because we have to prove theorems before we can use them. Here, I can use a postulate without proving it. So this is a postulate. Fix that on your sheets if you wrote that down as well. So here what I'm saying is that we've gone through and proven that these two angles are congruent, and that tells me that the lines A and B are in fact parallel. Okay, so in class we're going to go through and fill in the rest of these proofs. If you would like to attempt them on your own, absolutely go ahead and do that. We're going to go through and finish 3 and 4 in class, and then 5, 6, 7, 8, 9, and 10 will be for you to work on. Alright, if you need any extra help, either watch the video again or you can see me after class.